As conventional oil and gas reserves continue to decline while demand for hydrocarbons grows, the industry has turned to different methods to access what was once considered uneconomical and inaccessible hydrocarbon resources, known as unconventional oil and gas. Unconventional oil and gas refer to hydrocarbons that cannot be extracted using traditional methods, where the well is drilled and hydrocarbons freely flow to the surface. These resources are typically found in more complex formations, such as tight rock, shale, coal seams, and oil sands. They are often trapped within the rock, making them more challenging and expensive to extract compared to conventional resources. Developing unconventional resources often requires drilling horizontal wells to increase surface contact area and performing fracturing after the well is drilled to create more pathways for the hydrocarbons to flow more easily toward the wellbore. Shale oil and gas are hydrocarbons that are trapped within the shale rock formations. Shale is a fine-grained sedimentary rock composed of mainly of mud, clay, and different minerals. Over millions of years, organic matter from ancient plants and microorganisms gets deposited in these rocks, and under extreme heat and pressure, this organic matter transforms into oil and gas. Due to the unique characteristics of shale rock, these hydrocarbons do not flow as easily as they do in conventional oil and gas reserves, making their extraction a more complex process. The extraction of shale oil and gas has become economical mainly due to advancements in horizontal drilling and hydraulic fracturing. Horizontal drilling allows for a well to be drilled vertically and then turned horizontally, extending several kilometers within the shale formation. This increases the contact area with hydrocarbons trapped in there. Hydraulic fracturing is used to create small pathways in the shale rock, allowing the trapped oil and gas to flow more freely toward the wellbore. This is done by injecting a mixture of water, sand, and chemicals into the well to create cracks in the rock. Tight gas refers to natural gas and oil trapped in a low permeability rock formations that include not only shale but also sandstone and limestone. Similar to shale, the low permeability of carbonates and sandstone makes it difficult for the hydrocarbons to flow to the formation, and techniques such as hydraulic fracturing and horizontal drilling are used. Coalbed methane, or CBM, is a natural gas found within the coal seams. As coal forms from decomposing plant material, methane gas is produced and trapped within the coal seam. Coalbed methane deposits are usually found relatively close to the surface and can be developed by drilling vertical wells and then fracturing the coal formation to increase the production. There are a couple of ways in which coalbed methane is produced. The first one is a biogenic process, and in this process, microscopic organisms called methanogens break down organic material in the coal seam, producing methane as a byproduct. This type of methane production typically occurs at shallow depths and in younger coal seams. And the other process is thermogenic process, and this process involves the thermal degradation of organic matter in the coal seam due to the high temperatures and pressures. As the coal matures, the organic molecules break down, releasing methane and other hydrocarbon gases. Thermogenic methane is typically found in deeper and older coal seams. Oil sands are composed of sand, bitumen, which is a heavy viscous form of crude oil, and water. The bitumen must be separated from sand and other materials before it can be refined into usable oil products. There are a couple of methods for extracting bitumen from the oil sands, such as surface mining and in-situ recovery. Surface mining involves the removal of the top layer of soil, followed by extraction of the oil sands using large shovels and trucks. The oil sands are then transported to the processing facility, where the bitumen is separated from the sand, clay, and water using the process called hot water extraction. In this process, the oil sands are mixed with hot water to create slurry, which is then agitated to separate the bitumen from the other components. The extracted bitumen is then processed, typically through a process called upgrading, to convert it into synthetic crude oil that can be refined into various petroleum products. In-situ recovery is used when the oil sands are located too deep underground for surface mining to be economical. This method involves the injection of steam and solvents into the oil sand deposits to reduce the viscosity of the bitumen, allowing it to flow more easily and be pumped to the surface. SAGD or steam-assisted gravity drainage is the most widely used in-situ recovery technique for oil and sand development. It involves drilling two horizontal wells, one above the other, into the oil sand deposit. After that, steam is injected into the upper well to reduce the viscosity of the bitumen and allow it to flow toward the lower well due to the gravity. Another method is cyclic stimulation, which involves the injection of steam into the well for a certain period of time to decrease the viscosity of bitumen in the formation. After that, steam injection is stopped and the well is put on production. This process is repeated in cycles, alternating between steam injection and bitumen production.